In this example, we have a fishing boat that was initially worth $15,625. It is worth $12,500 in year 2 of ownership and $10,000 in year 3 of ownership. We are going to write a recursive formula for the geometric sequence that represents the value of this boat in each year of ownership. We know it's recursive because if we check for a common ratio, we do have one. And we're going to need to calculate that to write our recursive formula, so let's do that now. To find the common ratio, you're going to take a term and divide it by the previous term. So I am going to take the second term and divide it by the first term. 12,500 divided by 15,625 is 0.8. Now, because I have 3 points here, I could also verify that by dividing the third term by the second term. 10,000 divided by 12,500 is also 0.8. It's definitely a geometric sequence because we have a common ratio between these equally spaced terms here. Now we're going to assume this pattern continues and we're going to write the recursive formula for the sequence. To do that, we are going to indicate what the common ratio is. In our case, it's 0.8 because we are going to multiply the previous term by 0.8 to get the next term. But we also need to indicate the initial value, which was 15,625. Then we're going to use the recursive formula to determine the value of the boat in year 7 of ownership. Well, and we know from our given information the first, second, and third year of ownership values. So at the third year, it was valued at $10,000. Then we need to multiply that by 0.8 to find its value at the fourth year, 8,000. Multiply by 0.8 again to get the value during the fifth year, and continue multiplying each term by 0.8 until you get the seventh term. And you'll see that the value of the boat in year 7 of ownership is $4,096 because term 7 of our sequence is 4,096. Let's see how this looks different with the explicit formula. When you're writing the explicit formula, first write down the initial value, $15,625, and then multiply that by the common ratio to the power of n-1. We're going to use the explicit formula to determine the value of the boat in year 9 of ownership, so the 9th term of the sequence. The explicit formula is helpful because you can calculate the value of any term in the sequence directly using this formula. You don't have to calculate the ones in between like you would with the recursive patterns. So for our example, we have 15,625 times 0.8 to the power of 9-1, which when simplified is $2,621.44 for the value of the boat in year 9.